So as I said, many of the companies now switching over to the independent protection layer as a control instead of the safeguard as a control, because IPL is more effective, auditable, recordable. So that is why. So independent, what is the independent protection layer? Let us see first that effective in preventing the consequence. So effective means it's auditable, recordable, and cover all aspects of the hazard in that particular deviation, independent of initiating event. So should be independent. Like in case of say we have a temperature controller in the system, same referring to our example, the temperature is controlled to the control valve in the steam supply line. So in case of high temperature, we say malfunction of temperature, also high temperature, also human error also. In that case, high temperature alarm of that particular steam supply line or reactor can be considered as a safeguard. But when we go for the independent protection layer, in that case, say this temperature transmitter of reactor is controlled by the steam supply. So it's a single loop. So in that case, this is not independent from the initiating event or cause, because our initiating cause is control valve full open, malfunction and full open. So in that case, we don't consider control in the protection layer, but we can consider this control in the safeguard. So that's the basic difference. So in case of protection layer, this is not independent, because depending upon this control valve action is depending upon the temperature transmitter of the reactor, and complete loop, there is one single system we can consider. So any failure in the loop, suppose we say temperature transmitter failure, malfunction, there is a failure in the control valve, failure air supply, there is a failure in the logic solver. So in everything is a single loop. So anything fails, complete loop fails. So we cannot take this as an independent protection layer in case of our protection layer control. Auditable, so means we should have a record. Effective means inspection testing should be regularly carried out and should have the records. Auditable, for the records means we should have a graph also for the temperature controller, which should be available. So all this makes the independent. So in general, independent protection layer should be effective, independent, auditable, should have the records, should have the basic inspection testing, means whatever we require to maintain that particular protection layer throughout its life cycle. Suppose life cycle is 20 years, so whatever is required to maintain that particular control, say control valve complete loop, throughout its life, that should be recordable, and record should be maintained throughout the life. Say maintaining means, suppose we say it's a calibration, it's an inspection, testing, if required hydro test also, all testing as per legal requirement or as per the recommended practice by the manufacturer. That should be there, and all the measurements, all the monitoring systems records should also be available. So effective, independent, auditable. So we can do one conclusion based on this definition of independent protection and safeguard, that all the IPLs are safeguard, but not all the safeguards are not IPL. So we have to be very careful when we select the independent protection layer. Safeguard, we have the freedom. There is no restriction, but when we switch over to independent protection layer, we have the restriction, like it should be independent, should be auditable, recordable, effective means all the inspection, testing, certification, preventive maintenance that should be carried out. Right? So there is a basic difference. So that is why more and more industries are now switching over to protection layer instead of safeguard as a control. Independent protection layers, now examples. So alarm with operator action, if some response time is proven. So basically in the protection layer, response time is very important, very important. Let me share one example for the response time, how you should calculate the response time. Basically, for instrumentation, standard response time is available. There are different books available for the response times also. You can refer that also. Or if your engineering team can calculate the response time based on the loop design and diagram, so you can refer that also. Basically, you have to just define in your risk assessment that order of precedence for considering response time. Maybe first you can give the first reference to the calculation by your in-house team. Second, you can give the national standard available for the response time. Third, you can refer the international standards also. Like that, you have to define. That will be the best, because when standards change from national to international, priorities also changes. So it is always not confirmed that Indian standard means the lower standard, international standard is a higher standard. There may change in the international standards also. Say for API, NFPA, UK-based HSE standards, all have different basic assumptions. So based on the assumptions, reliability may change. So you have to define in your risk assessment what will be the order for the selection of response time also. Similarly for other selections also. So basically response time, let us take one example. Suppose we take one very basic example to understand that can be applicable to instrumentation also. So I'm taking one manual example, monitoring example. Suppose our same case study, there is a reaction flow, we increase the flow of the raw material, increase in the temperature, pressure. So suppose there are two different sets of monitoring available in this case, and our increase in the temperature suppose our design envelope for maintaining the temperature is 40 to 60 degree, right? And we say run our reaction is 105 degree. So increase in the temperature starts from our design envelope cross from 60. So 60 to 105, that is a very critical for us. So whenever our operator, we say there's a monitoring program for this particular reactor. So there is a one program that every 15 minutes, one program is every 1 hour. And suppose we say our temperature start increasing from 60 degree in reaches 105 degree in 45 minutes. So there are two sets of monitoring program. One set is every 15 minutes, one set is 1 hour. So now let us evaluate which one is effective in this case. So first, every 15 minutes, so suppose a temperature start increasing from 60 to 105. So suppose start at, suppose our operator takes a reading at 10 a.m. and temperature start increasing at 10:05. So 10:05, then second reading in case of your first set is at 10:15. So he can detect increase in the temperature. But in case of 45 every hour, our second reading will be at 11 a.m. and our temperature reaching up to runaway reaction is 5 plus 45, 50. So temperature runaway reaction takes place at 10:50 and second set says that we should take the reading at 11 a.m. So in that case, first set 15 minutes is okay because our response time is 15 minutes and our runaway reaction comes in 45 minutes. But second case, 1 hour, 60 minutes means our runaway reaction already takes place before we monitor the temperature. So events happen before temperature we monitor in case of second set. First case, definitely we can detect it. So our response time is such that our event should, our response time should be faster than the event takes place. So that is the basic in the consideration of response time. So along with operator action is of course there, but response time should be proven in this case. Same is applicable for all the instrumentations. We can calculate the response time for individual instrumentation based on the loop design and diagram. So we should consider this in case of critical at least. If there is severity 4 and 5, we should evaluate for all the response time and we should confirm that response time, response of that control happens before event happens. So that's the first example. Trip and interlocks. Of course, automatic shutdowns are there. So there are defined response times. So based on that, we can consider that. Relief system. So PSV, rupture disk, of course. So in the case of relief system also, independent protection layer plays a major, sorry. So there, say, suppose we take the example of PSV. So PSV can, design of PSV is very important in this case, relief system. Say PSV can be designed to release the pressure during your design envelope also, or maybe just release of the gas only. But in case of explosion, PSV may not be designed. So PSV are designed normally for pressure relief in the process or explosion conditions, external fire conditions also. So in case of PSV, you have to check the design condition of the PSV. If there is a PSV designed for the relief of the gas only during the process, and if we are considering the external fire, we are considering the explosion in that particular reactor. So we cannot take the credit of PSV because it is designed for the gas relief and we have the consequence of explosion. So that we have to be very careful when we consider such type of IPL. In case of safeguard, we can consider. But in case of IPL, we cannot consider PSV if it is designed for pressure relief or not designed for the external fire or explosion case. So we cannot consider that for the explosion or external fire. So that's a basic difference between the IPL and safeguard. Physical barriers, of course, guards. So physical barriers, suppose we have the dike wall. So dike wall, if it is dike wall, we can consider this as a safeguard, but dike wall should contain the legal requirement, also confirm the legal requirement of the dike wall. Say we say legal requirement is 80% of the total liquid in the tank farm. So that should comply that legal requirement. Then this is IPL. But safeguard we can definitely consider in any case if it doesn't comply the legal requirement also. In-house safer design, in-house design safety. So there's a lot of thing comes in the in-house design safety, like pressure increase in the reactor up to 2 bar, and our reactor is designed for the 4 bar. So this is in-house design safety. So that we can consider, and case to case we can consider the credit also. Training and procedure only if reliable and enforced. So training and procedure, if we don't write reliable and enforced, that safeguard is okay. But in case of protection layer, reliable and enforced. So for understanding the meaning of reliable means it is properly training is given and regular refreshing training is conducted, right? Enforced means of course monitoring records are also available, auditable, and of course response time is as per the event happening time. So based on the event happening time. So reliability and enforcement is very important in case of protection layer for the training and procedures. That is a basic difference in that case. So these are the few examples of IPL. Okay, now switching over to the type of IPL. So same we can refer what we discussed in the safeguard: active, passive, preventive, mitigative. So active, passive we already discussed. Preventive and mitigative already discussed in the safeguards also. So active and passive let us discuss in the IPL. There are two types of protection layers: active and passive. So active means which respond to our events or cause, like your control system or alarm, our monitoring system. So that either it's a human intervention, so person also can respond, and our instrument control system also can respond. So any response to our cause is a active protection layer. Or passive means like it doesn't respond but just be there, like we have dike wall. The dike wall is there, so dike wall doesn't respond to the leakage, but that contain the leakage. So like there are a few examples, like a fireproofing system. Suppose we have the fireproofing on the structure, so that's a passive safeguard because fireproofing is always there. It doesn't respond to the release or leakage of fire, but it protects that particular structure, say for 1 hour or 2 hours of the fire from the damage, just protect from the damage. So it's a passive, be there but not response to our any cause or consequence. That's the basic difference between active and passive either safeguard or protection layers.